Today we will be looking into fillet weld. The last class we have discussed butt weld. Here design of a suitable longitudinal fillet weld to connect the plates. The two plates are here. This is plate 1, which is having a dimension of 160 mm, and the smaller plate is here, which is having a width of 100 mm. What you have to do is you have to design the weld. So how much of length is required for this weld, which you have to design here. And in the figure it is given that if you are doing any weld, it should be equally welded towards the centroid. If this is the centroid of the plate, whenever you are welding, it should be equally distributed both at top as well as the bottom. If force is acting one direction, which is x direction, in this direction if the force is acting, and your weld should be along the direction of the force in both the axes, positive as well as negative. If the force which is acting in upward, you should weld at two ends. So the ends of the plate should be welded. So you note that to transmit a pull of equal to the full strength of the small plate. So they have not given any force here. What they are indicating is it should carry the full strength of the plate. So first you should find the strength of the plate. How much strength is there in a plate? The same strength which has to be carried by the weld also. Okay. The given plates are 12 mm thick, grade Fe 410. The plate thickness as well as the grade is provided, and assume that it is made in shop. Okay. First, designing the weld. In the code book, page number 78, you can see this kind of table, which is table 21. Minimum size of first run or single run fillet weld. So this table has to be used for fillet weld only. What they have given? Thickness of thicker part. So what is your thickness of the plate? Two plates which is having same thickness. What is the thickness? 12 mm. So you have the second case, over 10 mm and in between 20 mm. So 10 to 20 mm thickness of the plate is there. What is the minimum size of fillet weld required? 5 mm. Between 10 to 20 you should take a thickness which is 5 mm. Okay. Next you need effective throat thickness. So this is a factor. What do you mean by effective throat thickness is, I have explained in the last class. If you want to make a weld which is having a height as well as the width, how to find the throat is 0.7 times of t, 0.707 t. So this is the thing you have to use. So the effective throat thickness in the class 10.5.3, can you find this class? 10.5.3. Take this class, and the effective throat thickness of fillet weld shall not be less than 3 mm. So what is the minimum thickness which is given in the table, which is 3 mm. If you are making a weld, it should be at least 3 mm. Less than 3 mm you should not make any weld. Okay, after 10 to 20 mm thickness of plate, you need 5 mm thickness. So first criteria is over. Generally shall not exceed 0.7 times thickness or 1 times the thickness of the plate. So what is your thickness of the plate? 12 mm. It should be 0.7 times the thickness, the effective thickness. Okay. How to find the effective thickness is, when you are welding the plate, do you have figure 17? Check the figure 17. Fillet weld on square edges of plate. Right now you are making fillet weld, isn't it? Of plates. So if these two are your cases, then you should not weld the total size of the plate. What is the total size of the plate? 12 mm. You should not fill total 12 mm. What they have given the guideline is, you should reduce 1.5 mm. So 12 minus 1.5. So this should be the case which is given. If you are connecting a plate with the angle section. Then, so what should be the highest thickness? 1/4 of thickness has to be reduced, and this should be, that is 3/4 should be your thickness of the weld. So can you find the difference? So in this problem, either they have given a plate or angle section. Check that in the given data. Either you have plate or angle section. Plate. So you have to use this case. So minimum thickness should be 5 mm and maximum thickness should be 12 minus 1.5. So you got minimum and maximum. You have to select between what? 5 mm to 10.5 mm. So this is your range. The minimum size to be used is 5 mm. So you write here table 22 by referring IS 800 table 22. Minimum size should be 5 mm. Then regarding maximum size, they have given a figure that by referring figure 17, isn't it? Check the figure 17. Yes. By referring figure 17 for fillet weld IS 800. So you write in bracket your thickness of plate is 12 minus 1.5. Design of steel structure, first you should know code book. Then you can proceed the design. So without reading the code book once, you cannot do the design. Why? Because lots of the steps will not be knowing to you. By the guideline of the codes, you have to start proceeding. So here the sum starts here by taking the guideline. You cannot start straight away. You should know the code book, what are the weld and what are the classes they have given. You should read that. Then by that assumption we are proceeding the design. Okay. So between 5 to 10.5 you can use 10 mm size of fillet weld. Since you know the minimum and maximum size, you can choose the, right now you have provided the size, that is 10 mm weld you can use. From this you have to find the throat thickness. So FI 410 grade is being used here, gamma MW. What is that? Material welding safety factor. Material welding safety factor is 1.25. So what is the table for referring this? Table number 5. Then thickness of the plate they have given as 12 mm and breadth of the plate, what is the least breadth of plate? Which is 100. So you have to take this. First you have to find the strength of the plate. How to find strength of the plate is, see, your force is axial. The force is acting at both the direction and it is tensile force. Take it as tensile force. What is the formula for finding stress? Load by area. Stress here you should take as, what is the stress carrying capacity of the plate? 410. So this is your stress carrying capacity. So stress equal to force by area. Okay. Now what is your area? If you need to find the force, the stress is given. You should cross multiply the area. This is what the formula. Fy is the stress. What is the formula for stress? Force divided by area. So the area has been cross multiplied here and Ag into Fy divided by gamma MO. What is this? This is plate factor of safety. This is not welding factor of safety. The factor of safety in welding is taken as what? 1.25. So you have plate factor of safety. So can you find that table? So go to the table. Table 5C. Resistance governed by yielding. When you are stretching two plate, what will happen? Yielding will happen. So when yielding, so what should be your partial factor of safety? 1.1. For weld, when you are designing the weld, what should be your factor of safety? 1.25. Find the difference between these two. Why they have given two factor of safety? One factor of safety is for weld, another factor of safety is for plate. So you have two components, isn't it? You have a plate and you have to weld. So plate has separate factor of safety and weld has separate factor of safety. So do you know gross area? What is the cross section of the plate? This is the least thickness of the plate. How to find cross section area? 100 into what is the thickness? 12 mm. So 12 into 100. So 12 into 100 will be your gross area into Fy. What is Fy? Fy they have given as 250 MPa. This is Fu. Now you substitute all the values, you will be getting this answer. Ag, that is gross area, is 12 into 100 into 250. Your Fy here is 250. 272 kilonewton is your strength of the plate. So 272 kilonewton of force which can be carried by the strength of the plate. So the same you have to design for the weld. Okay. How to find effective length of weld? That is LW. Weld length. W is weld, L is length. Now for the weld you should find the throat thickness. So what is the size of weld you have chosen? 10 mm is the size of weld. How to find throat thickness? So what is the class? 10.5.3, isn't it? So what is the formula there? 0.7 times T. So what is your T here? Thickness of weld is 10. So what is 0.7 of 10? 7 mm. So this is your effective throat thickness. Design strength of the weld. How to find strength of the weld is, so what should be the total load which should be carried by your weld? Design strength of weld should be 272. So your plate is having a force carrying capacity of 272 kilonewton. So this is your formula. So where it is given? So you have the code book. Take 10.5.7 design stress in weld. Can you find this formula? FWD is design weld stress. So the design weld stress equals nominal weld stress divided by weld material partial safety factor. So what is weld material partial safety factor, which is in table 5, which is 1.25. You know this. Now what is nominal weld stress? They have given here as Fu by root 3. What is Fu? 410. Fu is 410, which is known to you. And how to find stress? Stress formula is load into area. So that is why here you will be having stress. So how to find load into area? The area you will be cross multiplying here. If you cross multiply area, how to find area of weld? Length of weld into throat thickness. What is your throat thickness here? 7 mm. The only one unknown is LW. What is the load it should be carrying? So here you have this in terms of formula also. FWD, which can be taken in terms of formula, which is length of weld into throat thickness. You know this. Okay. Now what is your strength of the plate? 272, that is 2,72,727. This is your strength. Now only one unknown is LW, 205.7 mm. So this is the length of weld. So you can distribute to each side. Since you need to weld the two sides, you cannot weld at a single side only. That is what I said. If you are welding, it has to be equally distributed along the line of force. So if you divide this by 2, you can provide this. Always provide, if 205.7 mm is required, do not weld only 205.7. You should be much larger than that in practical cases. So if in a design, so they would have given 212 mm spacing for reinforcement. When people are working, so you have to go to the next round of number and you have to do. These are some practical difficulties. The laborers cannot work for 0.7 or 0.8 like that. So you have to go for a round off value. So this is minimum requirement. So you can go for 210. If it is 210, each side you can provide 105 mm length of weld here. A tie member of roof truss consists of two ISA. What do you mean by ISA? Indian Standard. A stands for angle. You write it down. If you are not knowing, write it down. ISA in the sense Indian Standard Angle. Angle is known as what section? What cross section? Angle is known as L shape cross section. The angles are connected to either side. So this is the picture. By this you can understand. See, in exams they might not give picture. They will only give in descriptions. So you should know what do you mean by ISA. They have given that a tie member in roof consists of two ISA. So this is one number and this is another number. The angles are connected to the either side of 10 mm gusset plate. So this is your gusset plate. This is the angle section. Given the angles are connected either side of 10 mm gusset plate. Okay. The member is subjected to a pull of 300 kilonewton. So this is the cross section of gusset plate. This is the longitudinal section. You can see that this is a plate. Both the sides you have this angle section and it has been taking a pull of 300 Newton. Each angle section will be carrying 150 kilonewton, isn't it? If you have two members which is connected and total force of 300, half will be distributed. So 150 and 150 will be there. So this is, here they have indicated as working pull, that is working force. Always when design you should take factored load. What is factored load? What is factored load? What is working load? Working load is the exact force which is acting. When you are designing, what you should do? Multiply by factor of safety. If in the description itself they have given a factor load of 300 kilonewton, then you no need to multiply again. But here what they are saying? A working pull, that is a working load. If working load is there, you have to multiply by 1.5. So design a weld connection, assume the connections are made in the workshop. So it is a shop weld or field weld, so it is given the difference. So yes, in the solution, the force is given, you have to find the length of the weld. What is the length which is required? First working load is given, you should find the factor load, you have to multiply by 1.5. So you will be getting 350. Okay, now what is the formula for finding length of weld? Refer the last problem. What is the formula to find length of weld? Force equals LW T Fu divided by root 3 into gamma, that is material factor of safety. So this is your formula. Load of 300 kilonewton is acting. You know the force. Do you know the strength of the plate? How to find the strength? Ag into Fy divided by gamma m. You can find the strength of the plate first. If a force has to be transmitted, how it will transmit? First it will transmit to plate and it will transmit to the weld. So you find the plate strength, then LW you have to find. What is T? Thickness of throat. How to find that? 0.7 times the thickness of the member. Since you have an angle section, what is the thickness of your angle section? They have given here. 100 mm is what? What is 100 mm? Which is the total height, which is known as 100 mm, and 75 mm is the width direction and thickness is termed as 8 mm. So this is the way you should read. 100 mm is the total height and this is the width, 75 and 8 mm is the thickness of the angle. Then what is the thickness of the gusset plate? 10 mm, this is 8 mm, which you should consider. 8 mm only. Now your thickness is 8 mm. This is fillet weld. How the weld is being made? Either it is fillet or groove weld. Fillet weld. So for fillet weld, what is the minimum and maximum thickness? You should check the thickness of your member. What is the thickness of your member? 8 mm and 10 mm. So within this range you should take the minimum. If you are connecting angle section and the plate, you have different formula. If you connect a double plate, you have different formula. If you are connecting two plates, you can multiply thickness minus 1.5. If you are connecting a plate and angle section, what you should do? You should only consider 3/4 of the thickness. You should subtract what? 1/4 of thickness. Now what is 1/4 of thickness? Thickness is 8 mm. What is 1/4 of thickness? Is 2 mm. So you have to subtract 2 mm with your total thickness of the. If your throat thickness is there, you should take like that. Okay. Now thickness of the weld. At the rounded toe of the angle section, the size of weld should not exceed 3/4 of the thickness. You should multiply into 8. 6 mm is your thickness of weld. This is the maximum size. What is the minimum size? 3 mm. So you can take 6 mm and you can start design. You can refer the figure at the code book. The thickness should not exceed 6 mm. Each angle carries a factored pull of 450 by 2. What is 450 by 2? 225. So a single angle should take the load of 225 and both the angle will be taking 450 kilonewton. Thickness of weld is 6 mm. S equal to 6 mm you have provided. And how to find T? T is 0.7 times 6. 4.2. Yes. Now you apply in the formula. So LW equal to T is 0.7 times 6. Fy equal to 410 divided by root 3 into 1.25. So what is the LW? See, in a truss you will be having a member like this and number of several members may connect. So your problem is like this. You have taken only one part of the gusset plate. The gusset plate might be so large, so that you will be only taking thickness of the gusset plate. So what is the thickness of plate? What is the thickness of the member? You will be taking this. Now you are designing the thickness of weld. So for each and every member which is connecting in a gusset plate, you have to design for weld. If 5 members are connecting in a plate, you have to design the weld for 5 members also. Now what is your LW? 283. Always you should provide the weld. In the last problem you have provided equal length of weld, isn't it? 105 top at 105 at the bottom. But now in this case you will be having L1 and L2, that is different length. Why? Because there is a concept called centroid. What do you mean by centroid? Centroid is the part where load is transferred. Centroid is the place where the force is being transferred. If any load is applied at the axis, this is the passage of the load. If your centroid of the angle section is 31 mm from the web, so this is your base part from the 31 mm. So what happens? Your force will be much higher at this axis, and here you will be having less number of force only. Say for example, you divide a rectangle section into half. So what will be the bottom size and top size when you have 100 mm rectangle? The centroid will be 50-50, yes or no? But if you have an angle section, if your top is 31 mm and bottom is 31 minus 100 will be what? 69. Yes. If your ratio is 69 and 31, the top part should have higher reinforcement, that is higher weld, and bottom part should be lesser. What is the ratio? The ratio is coming here. So the L1 and L2 will be laid in a ratio to make the center of gravity of the weld coincide with the angle. Angles centroid should coincide with the force of the member. Now, what is the ratio is L1 by L2. If you are cross multiplying here, you will be knowing the ratio. This is L1 and L2. L1 by L2 ratio should be equal to, height is 100 minus 31, which is 69 by 31. This will be your ratio. Now you know L1 is 2.22 L2 plus L2 equal to 283. Now what is L2? 87 as L2. If L2 is 87, what will be L1? Now you substitute L2 in that equation. L2 plus L1 equal to 283. Now if L2 is 87, what is L1? 195. A time member consists of two ISMC. What do you mean by ISMC is Indian Standard Mild Channel. Channel is known as C section. You can see here. So the total depth, that is overall height of the channel, is 250. So in your code book in annexure H you have rest of all the components. So you take annexure H and look that ISMC will be separately there. It is jointed like this, back to back. The channels are connected either side. It means it is connected back to back. Of 12 mm thickness gusset plate. So you have a 12 mm thick gusset plate here. The previous problem was the same one. You have a gusset plate and it is being connected with what member? Angle section, isn't it? Now the same gusset plate is being connected with which section? Channel section, that is C section. They are connecting that. With a thickness of 12 mm gusset plate, design the weld joint to develop full strength of the tie. Now, however, the overlap is limited to 400 mm. Now they are giving a limitation that you should join the member. Only 400 mm gap is there. If you are placing in a gusset plate, you cannot extend for 500 mm like that. There is a limitation. They have given 400 mm is the limit. So now how you can provide that? Can you check the annexure H? Do you have ISMC 250? ISMC 250, and you have the cross sectional area. They have given it as 38.67 in centimeter square. They have given in terms of centimeter square. You can make it in terms of millimeter square. They have given the self weight, weight per meter, and depth of the section they have given as 250. What is the width of the flange? 80. What is the thickness? Thickness of flange is 14.1. Thickness of web is 7.1. Now what is the least of the thickness? Where the gusset plate will be connected? Is gusset plate is connected at web or the flange? Web only it will be connecting. Web is the largest portion. You see here, this is known as web and this is known as flange. So the flange thickness is how much? 14.1 mm. What is the web thickness? 7.1. So you are connecting a gusset plate which is having a thickness of what? Gusset plate of 12 mm. Now what is the least member? Is 12 mm is least or 7.1 is least? 7.1. Now your critical section is 7.1. Note that the gusset plate is not provided at the flange. Where it is provided? At the web. So you have to check the web thickness only. Web thickness only, that is 7.5. All the parameters are given here. Now let us go to this problem. From the Indian standard steel table, you can take the data. All the data you can take. Thickness of the web is 7.1. Thickness of flange is 14.1. Cross sectional area they have given in terms of 38.67 in terms of centimeter square. How to convert into millimeter square? Into 100. So it will be 3867 mm square. Now, how to find the tensile design strength of channel? So channel is a section. How to find the capacity is finding the capacity of member. You have formula as AG Fy by 1.1. So what is the cross sectional area of the channel? 3867. So this is your area, and what is Fy? 250 Newton per mm square. 8,78,864 Newton. So this is the strength of your channel section. Now let us go to weld design. What is the formula for weld design? How to proceed with that? Weld design formula is strength equal to strength of the member equal to LW T Fy divided by root 3 gamma. Now what are the components you know? Do you know LW? No, you have to find it. Do you know T? Thickness of the throat thickness of the weld. For throat thickness, what are the guideline it is given in code book? What is the minimum thickness? What is the maximum? Now you find it. What is the minimum thickness of weld? Since you have gusset plate and the channel, what is the least of that? 7.1, isn't it? Gusset plate is 12 and 7.1 is the least. So your range comes between first condition, isn't it? That is 3 mm is minimum required. So minimum thickness required is 3. Now what is maximum thickness? So are you getting angle section or a plate kind of a joint is here? This is a plate kind of joint. So you can use minus 1.5. So 7.1 minus 1.5 is 5.6. Now you can provide from 3 mm to 5.6. So what is your design? 4 mm or 5 mm? 4 you can provide. If you are economical designer, provide 4. If you are safety aspect designer, you take 5. So like that you can take. Now it has been tried with 4 mm weld. You can try with 5 mm weld also. That is not an issue. First let us look into economical point of view. Take S equal to 5. Now if S is 5, what will be T? Throat thickness. Throat thickness will be 0.7 times of 4, which will be 2.8 mm. Now you substitute in your equation, you will be getting LW of weld equals LW T Fu divided by root 3 1 by gamma MW. Now you know this is 1.25. All the components are known to you. What is the answer you are getting? So this is the strength of the channel section, 1658 mm. This is your length of the weld. Now what is the condition they have given? What should be the maximum length of weld? 400 mm is maximum. That is, you can weld channel section with the gusset plate for maximum 400 mm only. If you are providing 400 mm at top and 400 mm at bottom, what is remaining distance you have to cover? 800 minus 1658 will be 858. It has to be covered. You cannot go beyond that. So you have to make slot weld. So this is known as slots. So you will be providing this kind of slot to increase the area of the weld. If you are providing 2 number of slots here, let us take the slot thickness as 30. So 30 mm slot you are providing. If you are providing 30 mm slot, how many length will be increased? 1, 2, 3, 4. So you will be getting 4 length of slots. If you provide 2 slot, you will be getting 4 number of weld, which can be increased. Now you can use this formula. This is total distance of weld, which is 1658. You have already provided 400 mm at top, 400 mm at bottom, plus 250. 250 is what? 250 is the another dimension, which is the height. Height is what? 250. Now what has to be covered? 250 minus 2 into 30. Why they are minusing is, you are not welding at this point 1 and 2. So these 2 points you are not welding, hence you are subtracting 250 minus 30, that is 2 into 30, plus 4 into x. What is this 4? How many length you are providing? 4 length of x distance. Now only one unknown component is x. Now you find the x. 167. If x is required as 167, this is what I said. You should take some round off value. In this problem, they have taken x as 185 for a round off value. You can take more than 167, 180, 170, like that you can provide. See, in civil engineering field, you might get experience in design of concrete structures is one different stream. Design of or constructing a steel oriented structure and steel design workshop, which will be very different. See, it is a two big channel in civil engineering stream. One is knowing how concrete structure is designed, how they are making, how they are casting, what are the process for curing, how to make plastering, everything is different field. And another different field is how the steel structure is being made. The steel structure will generally be in large scale. Erection of towers, mobile towers is large work. Erection of a workshop. See, if all the companies are there, take an example, Bosch company, you can see Amazon, they will be having their workshop, which will be very large and all the structure will be steel only. There are two part of experience. Most of the civil engineers will be not having experience in steel design or steel erection, steel works. So, a civil engineer who is knowing both concrete and steel work, they are lucky. You people are luckiest person to know this thing. Number of person can pass by studying this also, but you will be not getting this knowledge, and this experience in steel design is quite different. Even though a civil engineer might be having an experience of 20 or 30 years, but they might be much not familiar with design of steel structure. Many of the consultant in field currently, they take only concrete structure oriented consulting only. They will not, some consultant will not take steel oriented consultancy. They need separate workforce, they need separate machines, separate team. So when you are getting both steel and concrete work, expertise is a rare thing. Most of the civil engineers will not have.